Hi, Mr. Richards here, and today we're going to talk about writing equations in point-slope form. What is point-slope form? Well, the linear equation y minus y1 equals m times the quantity x minus x1 is written in point-slope form, where x1, y1 is a given point on a non-vertical line and m is the slope of the line. And you can see it here where you have y minus y1 equals m times x minus x1. Now, the difference between point-slope form and slope-intercept form, in point-slope form we still have the slope of the line, which is still m. But instead of having a y-intercept, we can use any point on the line for point-slope. So if we want to write an equation in point-slope form for the line that passes through negative 2, 0 with a slope of negative 3/2, then graph the equation. Well, let's start this by writing out our point-slope form, which is y minus y1 equals m times x minus x1. Now, this y and this x we're actually not going to substitute into right now. The negative 2, 0 is going to go into our y1s and x1s, and our slope will go into m. So we're going to have y minus, our y1 is 0, equals our slope of negative 3/2 times x minus a negative 2. Now let's go ahead and simplify this. We have y minus 0 is just y equals negative 3/2 times x. Now minus a negative 2 is the same thing as plus 2. So here's our equation in point-slope form. Y equals negative 3/2 times the quantity x plus 2. We go to graph the line. Well, we can have our point at negative 2, 0, which is right here. Negative 2, 0, and our slope of negative 3/2. Well, we could either go down 3 into the right 2, which is down 3 to the right 2, or we could go up and to the left. So up 3 to the left 2. We can draw our line through those points, draw the arrows at the end, and we have our solution. If we do another one like this, write an equation in point-slope form for the line that passes through 4, negative 3 with a slope of negative 2, then graph. Let's again start with our point-slope form, which is y minus y1 equals m times x minus x1. So we have y minus our y1, which is going to be negative 3, equals our slope of negative 2 times x minus 4. Now to simplify this, we have the minus negative 3 here, so I'll change that into y plus 3 equals negative 2 times x minus 4. And that's simplified point-slope form. In order to graph this, create a point at 4, negative 3. And a slope of negative 2, well, we have negative 2 over 1. So we can go down 2 into the right 1, down 2, right 1, down 2, right 1, or you could write that 2 over negative 1, same thing. So we can go up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. And now we have a pretty nice set of points to kind of draw a graph through, with their endpoints being the arrows. So in summary, when we want to write equations, if we're given the slope in one point, we can substitute the value of m and let x and y coordinates be x1, y1, or substitute the value of m, x, and y into the slope-intercept form and solve for b. So we can write, if we're given the slope in a point, our equation into slope-intercept form. And then we can rewrite in any of the forms we'd like. If we're just given 2 points, we can find the slope, choose one of the 2 points to use, and then write it in slope-intercept form, or write it into point-slope form, or standard form, or really pretty much anything. In our second example, 2a here, we're given an equation in slope-intercept form, and we're asked to write this into standard form. So we have y equals 3/4 x minus 5. We want to get this into standard form. Now standard form, remember, ax plus by equals c. So we need to get our x and y on one side of the equation and our constant on the other. Well, let's start here. We want to get the minus 5 alone, so we need to get this 3/4 x over to the other side. And the way we're going to do that is to subtract 3/4 x from both sides, which leaves us negative 3/4 x. It's a plus y equals negative 5. Now, problem here is I have negative 3/4 x, and I need to get rid of the negative 3/4 x. So, what we're going to do is multiply every single term by the denominator, which is 4. And let's see what happens when we do that. Four times negative 3/4, that's negative 3x. 4 times y is 4y. And negative 5 times 4 is negative 20. So I have my equation now in standard form. Negative 3x plus 4y equals negative 20. I can have integer coefficients, but I cannot have fractional coefficients in standard form. In this next example, we want to write y minus 3 equals 2 times the quantity x plus 4 in standard form. And before we can move anything onto either side, we need to distribute. And so we have y minus 3 equals 2 times x is 2x, and 2 times 4 is 8. Now, we need to work to get all the x's and y's on one side, and then our negative 3 over here. So if we have the y minus 3 equals 2x plus 8, let's go ahead and subtract the 2x from both sides. And that leaves us with negative 2x plus y minus 3 equals 8. I can then add 3 to both sides. And I'm now left with negative 2x plus y equals 11. And that is my answer in standard form. Because remember, standard form is ax plus by equals c. Now, what happens when we want to take an equation and write it in slope-intercept form? Well, remember, slope-intercept form is y equals mx plus b, where m is your slope and b is the y-intercept. Let's distribute this thing out first. So 4/3 will be multiplied by x in the negative 3, so we'll have y minus 5 equals 4/3 times x is 4/3 x, and then 4/3 times 3, well, this can be minus whatever 4/3 times 3 over 1 is. Y minus 5 equals 4/3 x minus, well, that 4/3 times 3 ends up being 4. And we want to isolate the y, because we want y to equal mx plus b. We can add the 5 to both sides. And now y equals 4/3 x plus negative 4 plus 5 is 1. And there we are in slope-intercept form. Write 3x plus 2y equals 6 in slope-intercept form. Well, we need to isolate our variable. We need to get our y alone. So let's get this 3x and move it on over. So if I subtract 3x from both sides, it cancels out, and I'm left with 2y equals negative 3x plus 6. we need to get our y alone. It's not alone yet, so we need to divide by 2, but we're going to divide everything by 2. So y is going to equal negative 3 halves x plus 3. Key here, make sure when you divide by 2 that you divide everything by 2. Now, time for point slope and standard form all in one happy equation. The figure shows trapezoid ABCD with bases AB and CD. Write an equation in point slope form for the line containing the side BC. We need to find the slope of BC first. And remember, slope is y2 minus y1 over x2 minus x1. And if I look at B, well, B is 4, 3, while C is 6, negative 2. And if I make this first one x1, y1, my second one x2, y2, remember that's always a good idea to do so you know what you're substituting in. M is going to equal y2 is negative 2 minus y1 of 3 over x2 of 6 minus 4. Negative 2 minus 3 is negative 5 over 2, so my slope is negative 5 halves. Now, you can use either point for x1, y1 in the point slope form. Let's just go ahead and take the 4, 3. And point slope form is y minus y1 equals m times x minus x1. So we have our y minus our y1 of 3 equals our slope of negative 5 halves times x minus 4. So there is our equation in point slope form. Now, could you put in the 6 and the negative 2 as well? Yes. If you were to do that, to do the 6 with the negative 2 here, you would have the equation eventually of y plus 2 equals, still again, negative 5 halves times x minus 6. The reason it's a plus 2 here is you would have had minus a negative 2, so that's another way of writing it in point slope form. You only need to write one of the point slope form equations. You do not need to write both. Now, in order to write an equation in standard form for the same line, we can distribute here. So if we rewrite actually our y minus 3 equals negative 5 halves x minus 4, if we go ahead and distribute this, we would have y minus 3 equals negative 5 halves x minus 20 over 2, or actually plus 20 over 2, which is just 10. Now, let's get all of our x's and y's on the same sides. We're going to add that 5 halves x to both sides. We'd end up with 5 halves x plus y minus 3 equals 10. Because we actually, if I create some more room here, we added the 5 halves x to both sides, so that can cancel. And we were left up here. Now, we need to add the 3 to both sides. And so what we're left with here is 5 halves x plus y equals 13. Now I need to multiply here by the denominator of 2 each term. We're not allowed to have fractional pieces here. So my final answer here in standard form is 5x plus 2y equals 26. 5x plus 2y equals 26. Now if we do something similar here, the figure shows right triangle ABC. Write an equation in point slope form for the line containing the hypotenuse AB. Let's find the slope of AB. Well, A is 3, 1, and B is 6, 4. And if I call this ordered pair x1, y1, this ordered pair x2, y2, slope, remember, y2 minus y1 over x2 minus x1. So slope y2 is 4, y1 is 1, x2 is 6, x1 is 3. And this simplifies into 3 over 3, which is just, hey, an easy one of 1. Now we can use either point, x1, y1, in point slope form. So we could use either 3, 1 with a slope of 1. So our point slope form is y minus y1 equals m times x minus x1. And if we're using the 3, 1, we would have y minus 1 equals 1 times x minus 3, which simplifies into y minus 1 equals just x minus 3. That's one of the equations you could write. You could also write using the point 6, 4 with a slope of 1. And again, you don't need to do both. But we would end up with y minus 4 equals our slope of 1 times x minus 6, which simplifies into y minus 4 equals x minus 6. And again, no need to write both. You can just come up with one. To write this in standard form, pick an equation here, either equation. We'll do the y minus 4 equals x minus 6. We need to get all our x's on one side so we can subtract x from both sides. And we're left with negative x minus 4 equals negative 6. And actually I forgot my y there, so let's go back here real quick. What we're left with is negative x plus y minus 4 equals negative 6. Easy mistake if I can make it here. Try not to make it yourself. Then we'll finish by adding 4 to both sides. And we're left with, I'll bring it up here since there's more room, negative x plus y equals negative 2. Neat thing is, even if you used the other point slope form, you should still get negative x plus y equals negative 2. Good luck.